Today I am going to be presenting M3Grounder, a mask-based multi-span and multi-granular grounding approach for document QA. Documents are everywhere, answers must be verifiable. In our day-to-day, we encounter documents in various fields in life, be it legal, medical, etc. And especially in high-stakes domains, we would really like to know where the answer is coming from instead of just the VLM answering the question. The problem with current document VQA approaches is as follows. Existing document VQA methods, for the most part, ignore grounding completely. Those that do grounding also usually resort to box-based grounding, which is coarse and fails on curved/complicated text. Prior approaches also lack multi-span and multi-granular grounding. For instance, if you look at the image here, there's a coarse rectangle that is generated which captures a lot of irrelevant background. So what does M3Grounder do? M3Grounder acts as a smart highlighter to your VLM. For instance, for a given question, the answer is generated along with the masks of the individual answer span. M3Grounder also works at 3 different levels, that is 3 different granularities: phrase level, line level, and block level. Answering and locating happens simultaneously in the M3Grounder architecture. That is, given a question and the document itself, the answer is generated along with the masks in the same time. Our contributions are: first, the M3Grounder architecture. The M3Grounder architecture takes in a question and a document image as input, which is fed to the VLM component within M3Grounder. M3Grounder produces an answer with interleaved textual ground tokens. These ground tokens are a special kind of token which are then collected and are sent to 3 individual MLP layers, one for phrase level, one for line level, and one for block level. These in turn produce one embedding for each ground token that is provided as input. These tokens are then provided to the segmentation module, which till now has taken the document image and processed it in the vision space and produces a bunch of vision embeddings. These prompts are then passed to the prompt encoder. Together they are given to the mask decoder, and the mask decoder generates 3 hierarchical masks for each ground token, which is shown as follows. Here, for the 2 spans that the model considers to be important for grounding, 3 different levels of hierarchical grounding masks are produced. The second contribution is the grounding doc-QA dataset, which is a large-scale resource which, with 200k diverse documents, 2 million multi-span question answer pairs, diversity in the forms of charts, reports, forms, tables, and infographics. Hierarchy is phrase, line, and block level. The distribution is as follows. The data engine for grounding doc-QA has 3 different components, one for text-rich documents. In the text-rich document space, we pass the text-rich document through an agentic parsing pipeline, which produces something called the fit HTML representation. This representation is then fed through the LLM, and the IDs are mapped back to individual boxes, which after post-processing yield high-quality masks that do not have any hallucinations for the coordinates. For the curved text documents, the data engine detects curved text segmentations, and these are then given as prompts to the vision language model, and a question answer is generated on the basis of that. For visually rich documents such as graphs, we intercept the renderer and we extract positional information such as ticks, legends, etc. These are then together fed into a VLM, which after post-processing yields multi-span boxes with masks. The next contribution is grounding doc-QA bench, which has a total of 2.5k documents with 5k question answer pairs, out of which 2,820 are single span, 2,180 are multi-span, 70% are straight, and 30% are skewed. In addition to these benchmarks, we also test our model on bounding docs bench, closure bench, and doc bench, which are other benchmarks for grounding. Results for M3Grounder are as follows. We tested on 3 different other benchmarks and one of our benchmark. M3Grounder performs very well on all of them, outperforming commercial models such as GPT-5 and Gemini 2.5 Pro on the grounding set, and beating all other models in their weight class. The difference between InternVL 3.5 and M3Grounder's version, as well as M3VL and M3Grounder's Q version, are both sizable, which show that our architecture yields a lot of improvements, which otherwise would not have been possible with a direct fine-tune. Multi-granular performance is also very well for both M3Grounder I and Q. M3Grounder maintains competitive general doc-QA performance in spite of being trained on a lot of grounding data, which is shown by this point. We compare against other models of similar size. Performance of M3Grounder is consistently among the top 2. So in terms of qualitative comparisons, the left model is M3Grounder, the right model is Gemini 2.5 Pro. Here to this question, the answer is given by both models, but as you can see, M3Grounder's mask prediction for grounding is a lot better compared to Gemini 2.5 Pro. Similarly, this is another example. Both models produce the right answer, but M3Grounder's performance on grounding is a lot better. This is another qualitative result to show that the model can generate the outputs at 3 different granularities. Conclusion is that ours is the first mask-based grounded doc-QA system. We introduce multi-span grounding. Multi-granular hierarchy is also present. Grounding doc-QA is the dataset that we propose. Grounding doc-QA bench is the benchmark dataset, and we are state of the art across all 4 benchmarks, including curved text and text. Thank you.